Welcome back, everyone, to another Code Meets World video. I'm back to solving the NeetCode 150, and I've gotten through 16 of the problems so far, and in the last video, I actually finished the last easy problem in the trees category, which was subtree of another tree. So now we're finally moving on after 6 videos in the trees section. And there are no easy problems in the try category, no easy problems in backtracking. So I think we jump down to, heaps and priority queues. So we will look at the kth largest element in a stream problem. So in this problem, we need to design a class to find the kth largest element in a stream. This is the kth largest element in sorted order, not the kth distinct element, okay? So we need to initialize some stuff, and then we're going to be adding things to our priority queue from the stream, and we always have to return the kth largest element. Okay. So in the example here, we see that if k is 3, and we're given these values, and then we add these 5, each time we add something, we should return the kth largest element in the stream at that time. I think this will be a lot easier to look at. So like in this case, what we want to do is return 4, 5, 5, 8, 8. But I think it's going to be way easier to visualize this if we jump down to the whiteboard and kind of draw it out. So let's just go through the example that they show. Which means we're given k equals 3. So we need to find the third largest element. Not the third smallest, the third largest. And then we're given initially the values, which are right here. 4, 5, 8, 2. And what we need to do is each time that a value is added, we need to make sure that this entire array is in sorted order and then take the third largest element. So let me first sort this. So that's how we're given the values. And then the first thing that we add is a 3. So if we add the 3 and we add it in sorted order, it would go here. Now we look and take the third largest element because k is 3. So that's this 4. So for our solution, the first one we would return is 4. And as you can see, that is the correct first value. Okay, so what do we add next? We add 5. 5 can go here. And in this case, the 4 is no longer the third largest value, but the 5 is. So we return 5 for the next one. Then we add 10. 10 would go here. And now the arrow moves, but if you notice it stays at 5, it just moved to a different 5. So we return 5 again. Then we add a 9, which goes right in there. And now the third largest value is 8. And last but not least, we add a 4, which would get inserted down here. But it doesn't really matter since that's way smaller than the third largest value, so that doesn't change. And we get 4, 5, 5, 8, 8. And if we look, that's the exact answer we're supposed to get. So that's what we need to do, which makes a lot of sense, and I could write the code to do this. But we need to do something a bit extra. And that is that we need to use a priority queue or a heap in some way to make this problem easier. So you might be asking yourself, how does that even help us? What can we even do? And I think I've noticed there's a little trick that we can do to make this problem a bit simpler for us. So if we start over again with our initial values, which we got from here. So I'm going to show a slightly different way we could do this, I think. So if we start with our values over again, and we sort them, just like last time. One thing that we know is because the k value is 3, we only really need to worry about the 3 largest values we see in the stream at any one time. So what that means is we could just always keep our length of our stream as 3 and drop any other value. So what that means is we could effectively ignore this too, keep these top 3 largest values, and then we always know that whatever the smallest value is out of these 3, that's the one we want to return at each step of the process. For example, when we add the 3, the first thing we do is we add 3, which would come here. That's less than 4, so we just ignore it and return 4, the smallest value. When we add 5, that goes here. And now we say, oh, okay, we're larger than 3. So we just remove the smallest value, and then we know that whatever the smallest remaining value is the one we want to return. And this continues. We add 10 next, cut the smallest value, so we're back to 3, and then return the smallest. We're going to add 9, again, cut the smallest, return the smallest remaining, and then on the last one we add 4, I think, which comes down here, and we just cut that and return 8. So if we keep track of we only keep track of k total values. So if k was 100, we would keep track of 100 values and return the smallest. And this is a really nice solution because it lets us use a heap data structure for the stream. Because in a heap data structure, and leave a comment down below if you want me to make another video about the heap data structure. I won't go into it in full right now, but with a heap, what you can do is it's basically a tree where the smallest value is always on the top. So something like this would be a valid heap. And if we added something else to the heap, like a 0, which is the new smallest value, we make a series of switches up the tree such that the 0 would eventually get all the way to the top, which switched with 1, which switched with 2, which switched with 4, like this. And again, leave a comment if you want to see a video about how the heap data structure works, but basically just know it's an efficient way to keep track of the smallest or largest, but in this case, the smallest value in a set of numbers, even as you add and subtract things from that stream or from that set of numbers. So I think this is what we're going to use, and there's a built-in function in Python called heapify, which turns a array into a heap. And then we can add things by saying heap add, I think, and heap pop. This might be heap push. Like that. And these allow us to add things to the heap and remove things from the heap. And the heap data structure, by definition, always leaves the top value as the smallest, even after both of these operations. So hopefully that makes sense. Now I'm going to switch over to the code and try to write this up. Okay, so now we're going to try to translate what we just described on the whiteboard into the actual code. So I think what we want to do first is It's giving us an init function. So I think we need to say self.k equals k. So we can, I'm doing this here so we can access these values in the add function. And then we need a priority queue, right? So we can say self.priority queue equals just an empty array. And now we're going to do the first thing that I mentioned, which is to convert array to priority queue. And how we do that is with the heapify function. So we can say heapify self.pq. So this is now a priority queue. And that's important so that it's always keeping track of the smallest value at the top. Right. And so the next thing I mentioned that we want to do is remove all the values from the original heap. Well, I guess technically we have to add them first, right? Do I get a nums? Yes. So let's add all values to the priority queue. So we can say for num in nums. And this is where I think we can say heap push. It might be add, but I think it's heap push. So heap push self.pq, and then we would say num. And then after we do that, then we could say remove nums until there are only k left. And remember, this is so that we always know that the top value in the heap, the smallest value, is the smallest value. We only want to keep track of k values in our heap. So then we can say for I in the range, if we say the length of self.pq, if we say minus self.k, because if we added 10 things to the queue, but say k was 3, we would want to remove 7 of those values. So then we could say heap pop, I believe. And then we would say from self.pq. So we would just take values out. I think that's all we need to do here. Now we can pop down, pun intended, we can pop down to the add function. And anytime we want to add something, we just simply want to heap push self.pq, and then the value that we're trying to add to it. So remember, like I showed in the example, each time we want to add to the priority queue, and then if the length is greater than k, we have too many values, so we want to remove the smallest one. And then once we do that, then the top value in the remaining heap will be the smallest, the kth, or the largest. It's the smallest value, which is the kth largest. Again, go back and check out the whiteboard part of this video if you need a quick refresher on why that's the case. So we basically add it, and then we can check if the length of self.pq is greater than self.k. If that is the case, then we will heap pop from self.pq, which means we'll remove the smallest value off the end. Then we can just return whatever the smallest value is. Yes. So we can say self.pq, and then we can index this, I believe, just like it was a list. So again, just to show everything I did here, initialize k, initialize a priority queue, heapify it, which means make it into a priority queue. We add all the initial values, which are these here. And when you add them, the heap data structure sorts them and puts the smallest at the top. Then we remove any of the extra values we don't really care about. So we're only left with k values. And we do that because if we only leave k values, we know the smallest of those is the kth largest element, which is all we care about in the problem. So then in the add function, we simply push the value onto the heap. The heap will sort it in the right order. If by doing that, we've made the priority queue larger than k, we'll remove whatever the smallest value is, which is what heap pop always does. It removes the smallest value. And then once we do that, we have k elements again in the priority queue. So we know that the smallest one of those is the one that we want to return to satisfy the problem. Now there's a reason I didn't say heap pop here to get the smallest value, because that would also work. But we don't want to do that because that would remove the value from the heap, and we don't want to do that so that the code continues to run with the right values. We just want to peek and see what it is. I don't know if there's a heap peek method, but if there is, that would do what we wanted it to do. We often say peek when we want to just look at the top of a tree or a stack or something. But yeah, I think this is what we want. So let's go ahead and run this. Bool has no length if, yeah. I have my parentheses all messed up. Let's try that again. Okay, wonderful, that passed the only test case that we have. Brilliant. So that's a solution that has pretty good runtime, pretty good memory usage. So I'm definitely happy with that. And hopefully that was easy enough to follow, and I will see you in the next video.